Welcome to Imminent channel. A global magnetic pole flip is not imminent, and it's very unlikely to cause a sudden catastrophe. But the field is changing, and there are real, mostly technological, impacts scientists watch closely. Here's a compact, sourced rundown. Thanks for watching. Request you to subscribe the channel. What scientists actually observe right now: the geomagnetic field has been weakening in places, and the magnetic north has been wandering, but that isn't the same as a full flip happening next year or decade. Reversals are complex processes that, when they occur, typically unfold over thousands to tens of thousands of years. Some studies give ranges like approximately 2,000 to 22,000 years for full reversals. Localized features such as the South Atlantic Anomaly, SAW, are important for satellites and are a subject of active study, but the SAW by itself does not prove a reversal is about to happen. How fast do flips happen? Paleomagnetic records show big variation. Many reversals took millennia. A few short-lived events, excursions, may last hundreds of years. There's no reliable way to say, this weakening equals flip within X years. The last full reversal, Brunhes-Matayama, was approximately 780,000 years ago. For centuries, Earth's magnetic field has acted as a shield, protecting our planet from charged particles streaming from the sun. But this invisible barrier is far from static. Scientists have discovered that the magnetic poles wander, weaken, and, on rare occasions, completely flip, swapping north and south. The last full reversal happened about 780,000 years ago, and while the idea of another one sounds dramatic, researchers caution that it's not an overnight event or an apocalyptic threat. Instead, reversals unfold slowly, sometimes over thousands of years, with long transitional phases where the field weakens and behaves chaotically. What has captured attention in recent years is the South Atlantic Anomaly, a vast region where the field is unusually weak. Satellites passing over this area are more exposed to radiation, sometimes suffering glitches in their electronics. This anomaly has led some to wonder if it's the first sign of a global reversal. However, experts stress that anomalies are part of normal magnetic dynamics and don't guarantee an imminent pole flip. Instead, they serve as a reminder that the geomagnetic field is alive and evolving beneath our feet. If a reversal does occur in the distant future, the greatest impacts would likely be technological rather than biological. A weakened field could allow more solar and cosmic radiation to penetrate near Earth, increasing risks for satellites, communications, and power grids. Airline crews flying at high latitudes might face higher radiation exposure, and navigation systems would require regular updates to adjust for a shifting magnetic map. Still, the fossil and geologic record shows no evidence that past reversals triggered mass extinctions or global catastrophes. Life has weathered these transitions many times before. In short, while Earth's magnetic field is changing, the idea of an imminent catastrophe is more science fiction than science fact. Researchers continue to monitor the field with satellites and models like the World Magnetic Model, updating navigation charts and tracking changes. For most people, the drama of a magnetic reversal would play out not as a sudden collapse of Earth's defenses, but as decades, or centuries, of scientific adjustments and technological challenges. It's a slow-motion story, not a Hollywood disaster. Earth's magnetic field is one of the planet's great protectors, a force that shields us from the sun's constant stream of radiation and helps guide everything from migratory animals to human compasses. Yet this field is not fixed in stone. It wobbles, weakens, and every few 100,000 years or so, it flips entirely, north becomes south, and south becomes north. To many, that sounds like the recipe for a global disaster, but scientists who study the deep history of the planet tell a different story. Reversals are natural, gradual, and, while disruptive in some ways, far from the apocalyptic visions often portrayed in fiction. The magnetic field is generated by the churning liquid iron in Earth's outer core, a geodynamo that creates a constantly shifting electromagnetic shield. At times, this shield weakens in patches, such as the South Atlantic anomaly, a region where satellites experience greater radiation exposure. These soft spots in the field capture public imagination, sparking speculation that they are the first tremors of a global pole flip. The field has weakened and strengthened many times without triggering a reversal. In fact, the process of flipping usually unfolds over thousands of years, giving life and technology ample time to adapt. If a reversal were to begin in our era, the consequences would be felt most keenly in the technological world. Satellites orbiting Earth could be more vulnerable to radiation, leading to malfunctions or shortened lifespans. Power grids could face new challenges during intense solar storms, with a weakened magnetic shield offering less protection from geomagnetic disturbances. Yet none of these scenarios suggest the end of civilization, rather, they point to the need for preparation and adaptation. Ancient rocks preserve the record of past flips, showing that life on Earth continued with little disruption. The last full reversal, nearly 800,000 years ago, left no sign of chaos in the fossil record. Even shorter events known as excursions, where the field temporarily weakens and shifts without a full flip, came and went without wiping out ecosystems. The resilience of life offers reassurance that a reversal, if it happens in the far future, would be a geological drama, not a biological catastrophe. For now, scientists continue to monitor Earth's magnetic field with satellite missions like ESA's Swarm, which track its strength and behavior in real time. The World Magnetic Model, updated every few years, ensures that navigation systems reflect the shifting poles. These quiet, methodical efforts are the real story, a slow-motion adjustment to a restless planet, not an imminent doomsday. If the poles do one day swap places, it will be less like a sudden cataclysm and more like a long, unfolding chapter in Earth's ongoing tale of change. Practical takeaways: governments and space agencies monitor the field, satellites like ESA's Swarm and models like the WMM, and update navigation models and mitigation plans. For most people, no personal action required. For engineers, operators, plan for harder space weather and harden critical systems against increased radiation and erroneous magnetometer readings.